Gpqa might be the meanest benchmark in all of AI. The name stands for Graduate Level Google Proof Q&A, and it was built by researchers around 2023 for a very specific moment. The moment when models started acing every older test, and those scores stopped telling us anything useful. When a benchmark gets saturated, everybody clusters near the top, and you lose the ability to separate a great model from a merely good one. So today we're breaking down what Gpqa actually measures, why domain experts spent so much effort making it brutally hard, and what a genuinely good score really tells you about a frontier model. Now, to see why Gpqa is special, it helps to contrast it with the benchmarks that came before it. Earlier tests in the style of MMLU are broad and useful, but many of their questions can be answered by recall or by a quick search. If the fact lives somewhere on the web, a capable model, or even a determined person with a browser can often track it down. That makes those tests great for coverage, but weaker as a probe of genuine reasoning, because a high score might just mean the model memorized a lot of the internet rather than that it can think through a hard problem. Gpqa deliberately closes that escape hatch. Every question is written to be Google proof, meaning the answer resists a simple lookup. To get it right, the model has to actually reason through graduate-level science rather than retrieve a memorized fact. That single design choice is what makes this benchmark such a demanding test of deep understanding. Here is how the questions are built, because the construction process is really the whole story. First, domain experts holding PhDs in biology, physics, and chemistry write genuinely hard questions from inside their own fields. These are not trivia items. They're the kind of problems that demand real training to even understand. Then other experts and skilled non-experts step in to validate each question, checking that it is correct, unambiguous, and truly difficult. Only questions that survive this careful screening make it into the final set of a few hundred. Crucially, the skilled non-experts get unrestricted web access and over 30 minutes per question, and even then they score only around 34%. Search simply does not rescue you here, which is exactly the point the authors wanted to prove. Meanwhile, PhD experts working inside their own field land somewhere around 65 to 74%. So the model is left with only one path to a high score, and that path is to reason its way through, not to look anything up. Let's pull out the 3 ideas that make this benchmark matter. Number 1, these are graduate-level science questions authored by domain experts. The difficulty is intentional and vetted, so a strong result signals real competence rather than lucky pattern matching. Number 2, the whole thing is Google proof by design. Because unrestricted search barely moves the non-expert score, you know a model is not simply retrieving an answer it found lying around online. Number 3, Gpqa tests deep reasoning at the very frontier. The hardest diamond subset is widely reported precisely because it helps reveal whether a model is approaching genuine expert-level scientific competence. And that is exactly the kind of question the whole field cares about right now, as models push into professional territory. All right, let's lock in what you should remember about Gpqa. Gpqa is a set of a few hundred graduate-level questions in biology, physics, and chemistry, written and vetted by PhD domain experts to be genuinely brutal. Because it is Google proof, skilled non-experts with full web access still score only around 34%, so search does not save you. That difficulty makes it a real measure of deep scientific reasoning, not memorization, and a key gauge of whether frontier models are genuinely reaching expert-level competence in the sciences. Whenever you want more clear, no-hype breakdowns of the benchmarks behind modern AI, You will find a growing library of them waiting at standarity.com.